66 million years ago, a 10-kilometer asteroid slammed into the Yucatan Peninsula, wiping out roughly 75% of all species on Earth. For a long time, the scientific consensus viewed this impact as a terrible, isolated cosmic accident. A rogue rock crossed paths with Earth, and the apex predators lost the lottery. Then, in 1984, paleontologists David Raup and Jack Sepkoski analyzed the fossil records of thousands of marine species. They expected to find random background extinctions punctured by occasional, unpredictable spikes. Instead, they found a pattern. This timeline maps 250 million years of history. Notice the Gaussian peaks representing mass die-offs. They are not scattered randomly. They occur almost precisely every 26 million years. Earth's biosphere is tethered to a hidden, deadly metronome. Mass death operates on a strict schedule, and if the pattern holds true, we are currently on the clock. To explain a 26 million-year cycle, researchers had to look beyond geology. They proposed an astronomical assassin, a dark companion star locked in a wide orbit around our sun. They named it Nemesis. The hypothesis suggested a dim red or brown dwarf, a star too small and cold to easily spot, moving on a highly stretched elliptical path. Every 26 million years, the orbital mechanics of this wide binary system bring Nemesis to its perihelion, its closest approach to the Sun. At this point, the star plunges directly through the inner Oort cloud. This is a vast spherical reservoir of billions of icy bodies at the extreme edge of the solar system. The gravitational force of the star violently destabilizes the region. Millions of these disrupted icy bodies are thrown out of their delicate orbits, initiating a prolonged comet shower. A dense swarm of debris hurtles inward, drastically increasing the probability that several will collide with Earth. The scientific community embraced the Nemesis hypothesis. It elegantly connected the vast mechanics of celestial orbits with the regular layers of death buried in the fossil record. Finding a cold, dim star at the extreme edge of the solar system requires highly specialized equipment. Astronomers spent decades scanning the sky with infrared satellites designed to detect the faint heat signatures of brown dwarfs. The most comprehensive of these efforts was NASA's Wide Field Infrared Survey Explorer, or WISE. Launched to scan the furthest boundaries of our neighborhood, it possessed the sensitivity to find a Saturn-sized object out to 10,000 astronomical units. The All-WISE survey, along with astrometric tracking from the European Space Agency's Gaia mission, returned definitive results. There is no companion star. The Sun flies solo. Telescopes failed to find the physical star, but an even deeper mathematical revelation was about to completely dismantle the theory. In 2010, researchers Adrian Malott and Richard Bambach re-examined the deep fossil record using modern, highly refined geological dating techniques. They confirmed the extinction cycle was real. In fact, their data showed the roughly 27 million-year rhythm was perfectly consistent over an astonishing 500 million years. This precise biological clock creates the regularity paradox. As our solar system orbits the center of the Milky Way, it constantly encounters gravitational interference from passing stars and giant molecular clouds. A companion star orbiting 1.5 light-years away is barely held by the Sun's gravity. Over 500 million years, those external galactic forces would buffet and pull at Nemesis, causing its orbital period to drift by as much as 15 to 30%. The extinction peaks in the fossil record do not drift. They are rigidly spaced. A highly sensitive, wobbling orbit cannot produce a flawlessly timed impact cycle. The extreme precision of the dinosaur-killing clock in the ground mathematically proves that a distant star in the sky could not possibly be the cause. With the companion star ruled out, the mystery remains. What unseen force is actually keeping this strict 27 million-year time? One surviving hypothesis is double-disk dark matter. As the Sun completes its orbit around the galaxy, it bobs up and down through the galactic plane in a wave-like motion, crossing the midpoint roughly every 30 million years. Physicists propose that a thin, highly concentrated disk of dark matter exists along this plane. The intense tidal forces experienced during these periodic crossings could be the true trigger destabilizing the Oort cloud. Conversely, the pulse of the Earth theory suggests the clock isn't astronomical at all. Instead, it points inward to deep mantle plumes, rhythmic upwellings of magma from the core mantle boundary that cause colossal flood basalt eruptions. These cyclical eruptions drown entire continents in lava and release massive quantities of greenhouse gases. The resulting rapid climate change and ocean acidification present a purely terrestrial engine for the cyclical die-offs. The debate continues today. Some statisticians even argue the periodicity itself might be an illusion, a data artifact caused by the chaotic, compressed nature of deep geological time. Nemesis was completely wrong, yet it stands as a brilliant example of a productive failure. It forced paleontologists, geologists, and astrophysicists to break out of their silos and collaborate. The frantic search for this phantom star inadvertently mapped our entire solar neighborhood, driving the creation of massive infrared and astrometric surveys that revealed thousands of other celestial bodies. Reflective, we never found the Death Star, but the search proved that Earth's history cannot be understood in isolation. The fate of life here is inextricably tethered to the rhythmic heartbeat of the galaxy.